let's talk about the complex number system. So all the numbers in the world are called complex numbers, but they break down into two big categories. One category is called the real numbers. The other category is called imaginary numbers. Now, the imaginary numbers are not really imaginary. They're called imaginary numbers because when they were first invented, they didn't have a use for them. But now we do have a use for them, but they kept the name. So real numbers are numbers like pi, square root of 4, 1/2, -3. It's pretty much every number you've ever seen in your life and used. So just all kinds of numbers like this. These are all real numbers. Imaginary numbers have I in them, like 2i, 2 plus 4i. They're square roots of negative numbers. This would actually break down to look like this. So imaginary numbers are going to have a little I in them, and real numbers are not going to have an I in them. The I stands for the square root of -1, and the major usage of imaginary numbers has to do with electricity, because electrons flow on a wire, and electrons have a negative charge. So we end up having I in the problem. Now, so these are the two big categories, real numbers and imaginary numbers. Now the real numbers over here, they break down into two big categories. One is called the rational numbers, so the rationals, and the other is called the irrational numbers. Now, rational numbers, the root word is ratio, and it means any number that could be written as a fraction. So 3 is rational because 3/1. You could write this as a fraction. 0.4 is a rational number because it could be written as 4/10. -3 is a rational number because it could be written as -3/1. 0 is rational because it could be written as 0/1. So all these numbers are rational numbers. Any kind of number that can be written as a fraction is rational. So even something like square root of 16. Since the square root of 16 is 4, and 4 could be written as 4/1, this is a rational number. So it includes terminating decimals like this, but it also includes repeating decimals like 0.3 repeating, because that ends up being 1/3. So repeating decimals, terminating decimals, and other kinds of numbers are rational numbers. The most famous irrational number is pi. So pi is approximately 3.14156592, and it goes on forever. So that is called an irrational number. So an irrational number goes on forever. It never repeats, it never terminates, and pi is a number like that. It's the most famous irrational number. But also square root of 2, square root of 3, square root of 5, any kind of radical that is not a perfect root is going to be irrational. Second very famous irrational number is the number e, which is about 2.72, but again, it's like pi, it goes on forever and never repeats. So you could have negatives as well, so like negative square root of 7, like that would be irrational as well. So these are the big breakdowns. Now from the rational numbers, you could get integers. So integers are positive and negative numbers like this, positive and negative numbers including 0, but not fractions. So they're positive and negative whole numbers including 0. And then from this, you do have the whole numbers. So the whole numbers would be all the integers, but not the negatives. So we would have 0, 1, 2, 3, like that, on and on. And then last but not least, we have the counting numbers, which I've kind of run out of space there. This would be underneath here. The counting numbers, I can't spell counting. Counting numbers, there we go. The counting numbers, some people call them natural numbers. But the counting numbers are natural numbers, are numbers that you use to count with. So 1, 2, 3. So it does not include 0 because you don't really need 0 if you're counting things. So counting numbers or natural numbers are numbers that you count with. So this is the complex number system. Make sure you know these different categories.